Okay, let's go. That today's topic is very important, very, very important. That definitely part three, oh no, part four, I think. I have mistake there. Part four, I think that's topographic main four maps. The main maps, it will always be there, no matter what topography you are using, topographer you are using. Okay, so in gross, it's like sagittal map or axial map, or at the same time tangential or local curvature map. These two are curvature map. This is elevation map, anterior elevation and posterior elevation, obviously anterior surface elevation and posterior surface elevation. Corneal thickness map. Usually these two and sorry, usually in between these two only one, and usually two elevation map and one thickness map is there. And something you can change. Definitely you can go to settings of the machine and you can change. But basically these are the four main maps. There are a lot of maps, and with the machine it changes, isn't it? But yes, in case of definitely in case of these fours are very, 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 very central. And then let's talk about the axial or sagittal curvature map. So basically, curvature map means it will give you curvature. This picture I've taken from Sinjav, Professor Sinjav, Corneal Tomography, fourth edition. So basically, it gives curvature map means it gives curvature of anterior surface and posterior surface, no matter what. But how it will create the curvature map, that matters. Okay, for sagittal or axial map, the name itself axial means, let's take this is the A point in the cornea, and I want the curvature of that A point. Then I have to take the radius of that A point, because if you want power, then definitely n less minus n divided by r. You want radius, isn't it? N less minus n is, we consider that some like 3.1.376 minus 1 or whatever. uh, but you need r. What is the r, and how will you manage to get that r? Then for sagittal and curvature, axial curvature map, it takes like this. It takes, there is a reference axis. This is the line, that is the central black b line. From a, you, this point, you draw tangential, and that point matches with somewhere in, crosses somewhere in b, and you get this r. And from this point, whatever this c point, again you have to touch to that axis, isn't it? So this is sagittal axial method. The curvature of power of the measured surface point A is calculated using tangent line to the point, and the normal to the point intersects with the reference axis. So that's why reference axis is matters. It's very important that reference axis, this is the reference axis, that black line, isn't it? So that distance, that AB, the distance from A to B, is now radius. And now we put this into the formula and you get the result. But here's the concept is, you have to have that reference line, that axis, like this line. So that's the concept. You need this line, so that from every point you draw that tangent, and from tangent to normal, this is the tangent, and the normal should touch to this line. So that's the concept. Okay, then you will get radius, and then radius of curvature you'll get, when you put in the formula, then you'll get power. Okay, that's the concept. That's why sagittal means there is a reference axis, axial. So the most traditional way to view topographic image, best way to get quick overview of corneal power. So it's best way to go quick overview. Okay, it's quick overview. Can also be misleading because it's average data to create a smooth map, making it less accurate than the power map. It's very important line. Just see what is, it's basically what it makes map more smoother. Okay, if there is like sudden changes or bumps, it will not show that quite accurately. But tangential map, which is after this slide we will go there, tangential map has very, very good accuracy in that case. So central data is more accurate than peripheral data on the axial map, because the abrasing algorithm in the software assumes that spherical surface and the cornea becomes more aspheric in the periphery. So basically, central data central to the, like for example, visual axis, central of the cornea. So that central data is more accurate in case of sagittal or axial map. Then periphery data becomes more and more problematic. So I'll explain this picture. I think I have this picture. No, I don't have. Wait. Let me explain this picture from. It's very, very important picture. I think it's very important. See, from S2, can you imagine if S2 actually has radius of curvature like this C2? But what happens if in case of S2, its radius of curvature must be S2 to A2. This is R. Okay, this R is longer, but since there is a reference axis and you must touch to the reference axis, then R is shorter. But see this S1, actually S1 has radius of curvature S1 to C1, which is very small. But because of the principle of axial or sagittal display, it has to has some point in a reference. So distance between this is even larger. So whenever the need of smaller r, it make it larger. Whenever there is a need of larger r, like this case s2 to c2, it make it smoother, it make it smaller. That's why in case of sagittal display we say that it makes map smoother. So why smoother? Because small regularity is hides the small regularity. So same thing is here. This is more curved, isn't it? This thing, the axial radius curvature, this is more curved. But uh, if you draw the line till this axial line, that's not the case. It's something like that, more smoother. Okay, this picture is very good. So, anterior axial map is reconstruction of corneal surface by algorithm and measuring the radius of curvature of cornea centered to the optical axis is very important. The one of the axis, not just optical axis. This strategy attempts to illustrate the spherical geometry of corneal surface. The transition from center to the periphery on axial curvature map is smoother. It's very important, smoother. And there is a gradual transition of color from center to the periphery of the normal cornea. So basic means the color transition is also gradual because it's smoother in case of sagittal. So I have taken this picture from the refractive surgery book by Azar. So can you see this picture is axial, at the same time this picture is tangential. So it shows the irregularity, at the same time it shows how smooth it is, just moving this color. Can you see this? Yes. At the same time this is the same thing. So see, this is, what is this? Left is tangential and this is so this right is actually axial, this is smooth. The left is, this one is tangential, isn't it? So can you see there's small irregularities? So same thing going to happen. This is sagittal and this is tangential. Can you see? And this here is very good example. I have seen, like, I don't know, thousands of cases. um, it's always there. I always love my student to show these things. See, this is the case. If you got tangential, like it's a focal point there in a small area, isn't it? In small area of elevation or whatever, a small area of that focal irregularity. But whenever that you switch from tangential map to axial map, it's like, wow, there is large area is covered, isn't it? Large area is covered. But actually the tangential is far important whenever you diagnose keratoconus. Actually this is the keratoconic picture, so it's very important. So now we come to the tangential or instantaneous. Another name of the tangential is instantaneous. Okay, the more sensitive to curvature map as it measures the power and the curvature of individual points of the cornea more accurately. It's very important. Actually, power and the curvature of any corneal point, it measures independently than other. In case of axial map, we have to have single axis and we have to draw that radius to that up to that axis. But Here's the case, different case. Okay, so early defines small or instantaneous curvature, changes the calculate that measures point data at 90-degree tangents from its surface. Tangential map provide more detailed description of corneal shape. That's very important. Tangential map is like always superior, and they provide clearer view of size and shape of the keratoconus patient. It's very important. Whenever there is irregularity, ectatic disorder, any, no matter what, you have to go to tangential map. Like optometrist, like example, what do you call that, orthokeratology, tangential map is gold. So limitations, yes, obviously appears more noisy and irregular because it's like focus. Isn't it the case of, see, there's the red band, yes, elevation, and I think this case of orthokeratology, isn't it? So I was telling about it. If you want a curvature, then there is a tangential surface and it will create its own circle. Then you have, r, isn't it? It will have its own circle. It means its own r. Again, I have taken this picture from the Dr. Sinjab's book. And geometrically, the specific sections of tangent circles are more accurate than the tangent line. So that's why actually curvature map is very accurate. And consistent, this method is highlight any irregularities in the cornea whenever is small, whatever is small it is. The value of the back surface are displayed in the negative digit, since the surface plays the role in concave surface, isn't it? Front surface is 48, back surface is minus 6. Why back surface is minus 6? N dash minus n divided by r. So here is my n dash means what? 1.33, and 1.376 divided by whatever r is actually minus. So back surface is minus. Okay. So back surface of cornea is minus. I think I have made it clear when I have talked about it in optics class. So can you see here? In case of tangential map, which is basically instantaneous map, irregularity is shown clear. Okay, it's very black means power is high, then this power is again high, and then this, and then flatter. So, what is the clinical difference between sagittal and tangential curvature map? It's very important slide. First, the tangential map is more suspicious to local curvature changes, it means irregularities, because it depends upon the circles. Therefore, it is more capable of revealing corneal irregularities. If you want to know corneal irregularities, especially in case of ectatic conditions, it's very important. And each point of the tangential map is calculated independently. Obviously, there is no reference axis in case of tangential map. So therefore, it is to some extent less affected by misalignment during taking captures. And sagittal map, if you misalignment, obviously misalignment affect both of the map. It is not that misalignment doesn't matter, but misalignment matters more in case of sagittal map than compared to definitely tangential map. Tangential map is better evaluating coordinate periphery. That's gold. That's gold. Just understand this concept, okay? Tangential map is way better than sagittal map whenever we come to periphery of the cornea. And tangential map is more capable of locating cone of the keratoconus. I have shown you, isn't it? This is this in this case, isn't it? Tangential map show cone exactly this, but sagittal maps say it's look like half of the cornea is involved, isn't it? So tangential maps show cone accurately. Okay, so locating cone more accurately and cone size, yes, definitely. So tangential curvature map, the measurement of the radius curvature is performed locally at each point, we know, and generating more precise information about the radius of curvature at each analyzed point. It's very important. The highlight possible outlier, generating a rougher map definitely, and showing the peripheral region with a great precision is always there. Rougher, which is noisy, I think one of the disadvantages, but peripheral region with a great precision, that matters. Whenever you are going to do pellucid marginal dizziness, my goodness, is very important. Okay, so another concept is elevation map, which is very important. Whenever I was there in hospital and analyzing corneal topography, then I always see posterior elevation. Very first target is to see posterior elevation, because posterior elevation is highly sensitive whenever you are trying to diagnose keratoconus, or you at least differentiate keratoconus from normal. And whenever you are there in analyzing for the refractive surgery, I always choose to see how is the posterior elevation, and that matters. Okay, so in four maps I always go posterior elevation very first. Okay, okay, fine. So let's discuss about elevation map. Elevation map means the surface cornea is mostly similar to the surface globe in terms of elevation. Basically means all the point above the reference surface is elevated, being displaced as positive, and all the points that are below the reference is displaced as negative. Isn't it simple? And all the points that exactly coincide with the reference point is like zero, like sea level, isn't it? Mount Everest 884 from sea level, at sea level zero, isn't it? And below sea level minus whatever. So it's very simple. Elevation map means like this. Suppose, let's take an example. This green is a reference, and your cornea goes like this, isn't it? And whenever this reference surface match, there is zero. Whenever this your cornea is below the reference surface, it's negative, isn't it? It's above the reference surface, it's positive. Very simple. Something like that. Reference surface is this, and green line is your cornea. Then above the reference surface plus, add equal to the reference surface 0, below the reference surface is negative, again above the reference surface is positive, isn't it? It's very simple. So clinician view elevation data not in its raw form, actual elevation data, but compared to the reference surface shape, depicting how actual corneal elevation data derived from the known shape. Basically means this sphere, whatever it is actually compared with the real cornea. See, if you don't have sea level, then how will you tell that Mount Everest is at 4 8? Is there any other reference? No, because sea level is a reference. That's why Mount Everest is at 4 8, isn't it? It's very simple. That's why we need that sea level. We need reference, and when it comes to reference, we always tend to talk about best fit sphere. So Bedford sphere is a central 8 mm zone map. Oh, I don't want to talk about exactly 8 mm. It's depend upon the settings. There are other options too. So you just go and make your settings as viable as possible. Okay, as good. And what you want to put your best fit sphere diameter, that matters. Okay, so I'll talk about best fit sphere a little bit. So best fit sphere means, the term best fit means the error minimizing approach is used to determine the radius and the center of the sphere. Firstly, what are the two big advantages that I'm going to talk about? It provides the constant radius of curvature reference, because we need reference. We need reference. Above that reference is positive, below that reference is negative, and that's how we understand the elevation of the cornea. So, which produce the characteristics pattern of the shape of various conditions such as astigmatism and posterior refractive surgery or keratoconus, whatever. Second, due to the nature of mathematical fit, best fit sphere can be considered a measure of average curvature of the region which over sphere is fit, and with about half of the corneal surface fitting above the sphere and half of the below the sphere. It means, basically means, your data from the capturing your data from the machine itself create best fit sphere, and it creates like average curvature of on and off average curvature of whatever actually cornea has that curvature. So, and then that sphere is fit into the our cornea, and we get, what do you get? We get elevation map. So basically, see, if this is reference shape, this blue line, then this is the cornea, then what happened? This area is definitely elevated, this area elevated, but central area is depressed, isn't it? It's just like any case here. Here is the case. I think it's a case of post operative laser in situ. So, and in another case, this is a reference, and cornea is elevated central area. It's like keratoconus case, isn't it? This picture I have taken from this book. So basically means from the reference, if cornea goes up, then it's elevated. From the reference, cornea goes down, then it's depressed and written. So showing accordingly. So basic concept is this: if yellow is a reference line, then this is positive. This is again positive. This is perfectly fit. So this is again perfectly fit. So this is a elevation map. Elevation map is very important. I will make one video on keratoconus, diagnosing of keratoconus with topography. Then we will discuss there. Corneal thickness map. So basically, what is the principle? The computer measures the thickness of the cornea at all point depending on the elevation map. That's very important. As a student, you have to understand things quickly. In case of corneal thickness given by any Simplon based topography is not OCT based. It's not based on OCT. It's based on difference. It's based on elevation map. Basically, difference between the front and back surface elevation indicate the corneal thickness. So, if elevation map get wrong information, then thickness map will definitely get wrong information. That's very important. And elevation map gets wrong information. One of the condition is the corneal scar in anterior surface. So the posterior surface elevation map will be very bad. So not reliable. So at that case, you cannot rely on the corneal thickness map. So it's very important. You need an OCT, which definitely plays better role. Okay. So main element, the computer displays the thickness map into two patterns. One, five values, a certain values expecting central thickness, and for values around 5 mm in the central circle. So basically means, see, this is how I have taken this from the corneal topography book. This is how very simple thing. Center with periphery, periphery, and cornea. As you move from center to periphery, thickness increases. It's very simple. Okay. So distribute value overall. So sometimes there is 4 5 values only, and sometimes there is lot of values. And I love this kind of. I don't know why I love this kind of picture. So main element of the three location that appears the main page is the thinnest location, corneal apex, and this is from pentagon. Okay, this is from pentagon. So in the particularly whenever you try to draw the conclusion and try to see things more accurately, then it's very important. Thinnest location, corneal apex, and the pupil center. These three things are very important. Okay, these three locations are displayed with the coordinates. Coordinates means this is the coordinate, isn't it? This is plus plus coordinates, plus minus coordinates, minus minus coordinate, plus minus coordinate. We know that coordinate system, isn't it? So there are three coordinate and coordinate apex. The origin is 0, which is definitely point, and from x-axis the right, and this is basically this stuffs. Okay, it's very similar. Okay, so clinical interpretation is the superior inferior ratio on the central 5 mm is a superior inferior value should be compared, and the difference of superior inferior values by 30 degrees cautious should be taken. Okay, so superior and inferior value, if there is a difference of 30 micrometer, then we definitely think that there is, if there is any problem is going on like keratoconus or anything. The difference of thinnest at the thickest location between the two eyes should not be greater than 30 degree. That's this rough idea. And the shape of the map. The case will be suspicious of the map of the conic shape, while PMD thickness. So basically, I don't know. I have to talk about it now. But in case many of the students think that the hallmark of pellucid marginal degeneration is like kissing pigeon shape or crab claw pattern or kissing pigeon pattern. That's not case at all. Hallmark of pellucid marginal degeneration you cannot find in the curvature map. You have to look into the thickness map. In thickness map, if it is bell shaped thickness map, something like that, bell shaped thickness map, then that's the hallmark of pellucid marginal degeneration. Many of the keratoconus patients I have seen, I don't know, I have seen out of 10, one, they have crab claw pattern. It's very common in keratoconus. It's sometimes people call it pellucid like keratoconus. I don't know what the term means, but obviously. So just understand topography, yes, but in case of corneal keratoconus, there is nothing bad in periphery, but in pellucid margin there is thickness map. Periphery is thinner, so that's why bell shape map in thickness map, pellucid marginal degenerations hallmark. Okay, don't say what do you call that, kissing pigeon pattern or crab claw pattern. So the difference between thickness in apex and the thickness at the thinnest location is more than 10. We will suspect that. Okay. So there are other things that is also important. That what is the interior inferior displacement of the apex, which is definitely in keratoconus is always inferior temporally. Yeah, always not. Sometimes it inferior nasally, but many times it's very clear inferior temporally and displacement of the apex thinnest position. So what are the limitations of the thickness map? So corneal thickness map is in corneal opacity. I have already told you. In case of opacity, posterior elevation is very bad, and if one elevation is very bad, don't rely on it. Since symptom imaging is light based and penetration through the cornea is affected by opacity, the denser the opacity, more image is affected, and itself corneal thickness map is artifact, and this present focal thickening or more commonly focal thinning. I don't care what it is, but just remember if there is any scar, don't rely on the thickness map. Therefore, if we are not rely on the thickness map, ultrasound biomicroscopy or gold OCT are more accurate in evaluating corneal thickness as well as thickness and the depth of opacity. It's very important. It's very important. You always rely on OCT. OCT is very good with thickness. Okay, and don't rely on Simflong corneal thickness. Yes, it can be grossly. You understand? Yes, there is some gross idea, but don't rely on it. So, see, in this case, it's actually way thinner area. So this is the OCT in this gold. Okay, you can see epithelium and stroma thickness. It's clear. So what is the clinical use is diagnostic ectatic disorder, obviously, observing progression of the disease, obviously, these maps are, and taking right decision, refractive surgery, and for refractive surgery, intracorneal stone, obviously, deciding the exact amount of corneal. Oh my goodness. The corneal topography is the most sophisticated instrument in the field of optometry. I don't know if this line is correct or wrong. I feel like that you can do everything with corneal topography. You must be the master in corneal topography, and then things happen. Then things will go well. Okay, till I think that's all I want to say. I will definitely make more and more videos on this. Today's that I have taken a lot of pictures from this, a lot of pictures from Sinjab's book, Professor Sinjab's book, and this is good book, and this is again good book. So I think these are the great references for you guys. Okay, so Bistan, choose.